Hey, let's try this again. What's up, Pre-Cal 12? We are here after school. There's no better place we'd rather be than math class twice in one day. This is pretty special. Sometimes you have special days. This is one of those moments. Right now we have some people that are here with us. Y'all didn't even smile, by the way. Yeah, y'all smiled. We're going to go ahead into our review. This is our help session for today. I'm going to use this blank slate and then also some specific questions off the review, homework, and all of that. And so without further ado, let's get it going. Do you have questions? Any number of questions that are out here? No, you had one.
Number 7.
All right, let's go through number 7. I'm going to scroll down here. Yeah, this is a good one. So remember I said that 3.1 to 3.6 really is what all of this test is over. It sounds worse than what it is because if you look back at your test, a lot of the stuff from last unit and this unit kind of overrides each other. So when we look at this, the big thing to remember is if I'm making this as one log, there is no equal sign. Whereas up here, over on number 4, which we can look at here in a second, that might be a good one, that does have an equal sign where we're actually solving. So in this one, we're just simply simplifying by first doing what with the numbers that are in front of the log?
Moving them as exponents.
Yeah, so those will all go towards the front or towards the back side of the exponent. So what we've got is log base b, 16 to the 1/4 power, that's important, not multiply, minus log base b of 5 to the 2nd power, plus log base b of 7, okay? Well, what's 16 to the 1/4? Think of that as like the 4th root of, or what number multiplied by itself 4 times equals 16. So a lot of times people say 4, but it's actually not. That'd be like square root. 4th root would be, it would be 2. Does that make sense or not really? If you did it on your calculator, 16 caret 1/4, you'd get it, okay? Or if you said, okay, what number multiplied by itself 4 times gets me to 16? Well, 4 would throw you out there. And so the only one that really would make sense would be 2 times 2 times 2 times 2, which is 16. Cool? All right. So we have log base b of 2 minus log base b of 25 plus log base b of 7. Well, what do I do with these first two when we subtract? How can I condense this down further?
So it'll be log b 2 over 25 multiplied by 7.
Yeah, so log base b, 2 over 25, and then plus 7 means that we would multiply 7 on the top, which would be 7 times 2, which would be 14. So log base b of 14 over 25. Okay? Cool beans. Questions on that? Good stuff. Do y'all want me to do this one on number 4 up here?
Yeah.
That one's a good one. Similar to what we were doing earlier with 2 logs on the left side, how can I make that to where we have 1 log? Combine them in terms of, like, how do
Log 2, and then
oh,
x
2, yeah. X times
times x
x plus 3. Good. So x times x plus 3, since we have 1 log, we set it equal to 3 here. Now, once we have 1 log on the left, because we don't have another log on the right, we can't cancel like we did on the previous one. So now we've got to do what with the 2? Shoot it over. We get 2 to the 3rd equals x times x plus 3. Well, what is x times x plus 3?
X squared plus 3x.
Good, x squared plus 3x, which helps us in knowing that, okay, we have a squared, we might have to have multiple answers. So how do I get that to where everything is on one side, right? We just subtract by 2. So we get x squared plus 3x minus 2 equals 0. And then
Is that
we
not 2 to the 3rd anymore?
say that again, I'm sorry.
It was 2 to the 3rd over there, and then.
Oh, yeah, I'm sorry. Yeah, because 2 to the 3rd is here. Thank you very much. This should be what? What is 2 to the 3rd? 8, good. So this should be minus 8 on both sides. That's why I've got y'all. Y'all are here. I was just making sure y'all were here and paying attention, and y'all checked it off. Good job. So what can we do to then find what factors go into each? Is this right? 4, 8. It's weird, isn't it? It's a little weird. I will say, I don't know if there's one like this on there. Usually it's going to be factorable Okay, but in this example, this one,
You need to do
yeah, let's see
the
here. I'm gonna
formula.
pull this up. You could do the quadratic. You could also plug it in and just see where it crosses the x-axis. Again, this is taking it probably deeper than what I thought it was going to be, but we could just plug that in. Can't factor it. Only the positive value would be the one that we would use here. Let's see if we can actually plug it in. So we're going to go close. So we'll do y equals x squared plus 3x. Sorry, 3x, and then minus 8. And then when we graph it, I'm sorry, this is not what it should look like. This was from the previous stuff. But we could go to zoom standard, which is 6. And you should see, don't exclude these, right? That's different. Just the positive answer, so I can go to second, trace. I know right now that's not really a huge deal, just knowing. All right, here we go. And our answer was 1.70, okay? Don't need the negative one. It would produce a negative value, so only that one that's there is what we need, okay? Cool? All right. I'm looking. We've already done this one earlier before the podcast. There's one similar to that right down. Well, there's this one. That one's a little bit different there. Number 19. We did number 19 today, right? Do you want me to do it again?
I have a question on
5. Let's do it. Let's go through 5. Oh, that's a good one. Okay.
So, once you get it to ln x, would it, so you have the square root, which would be 1/2.
Correct.
So, what would you do with the x squared then?
The x squared would just remain on the top, and the y would be on the bottom, right?
Okay.
So the square root produces a exponent of 1/2 to the 1/2 power. So in order to set this up, we're going to say, all right, this is the 1/2 can go where, first off?
In the front.
In the front. Good. So we have 1/2 ln of x squared over y. Now, how can I divvy this up? How can I expand this out?
ln x squared minus ln y.
Minus, and be
Or,
careful, the
1/2
1/2 goes there too. Yeah, good. 1/2 ln y. Now, what happens with the 2?
Because
This 1 can shoot to the front, right? So 2 times 1/2 would be 1, right? And that would just be ln of x minus 1/2 ln of y. And that would be it.
okay, so you can actually shoot the 2 over.
You can. It's like doing it a second time, but this, since it goes to everything, we do that first. Okay? Cool? Cool. All right, good stuff. Any other things y'all see?
Can you do 9?
Let's do 9, yeah.
9, we can do 10. Probably 9,
9 and 10?
Actually, I do.
We could look at 9 and then go to 10 if need be. All right, first off, I want y'all to lead this one. Go ahead. What would we do first?
1/5.
Good. So everything inside to the 1/5. Good. What do we do next?
Shoot at the front.
Good. Shoot it to the front. What do we do now?
So now it's e to the third
Mm-hmm.
plus 1/5 ln to x.
I like it. I would say the 1/5 goes to both, right? So we would say 1/5 ln of e to the third plus 1/5 ln of x. Y'all follow me on that?
Yeah, and then the 3 goes to the front.
Good. The 3 shoots to the front, which would be
3/5
e plus 1/5 ln of x. Good. What happens with ln and e?
They cancel out.
That does cancel. Good. And that's why it would be 3/5 plus 1/5 ln x. Okay? Good? Did I erase that too
Can you
soon?
use 10 really quick?
Yeah, absolutely. So 10, a little different. Notice here that in this one there is no variable in the log, which is kind of a little strange because that normally is not the case. But because there's no variable in there, we can actually go ahead and pull up. I'm going to pull this up here. Hold up, let me erase this. Okay, let's see here. We can actually pull up second. Oh, I'm sorry, not second. My fault. Just pull up math and then go up to log base. I'm going to take this other part out. I don't know why that shouldn't be there. Delete that. So log base, and this was 2, right?
2 to the
32nd. Good. And so that would be 5. That would be the answer of 5. So what's nice about that, then we can just, because it doesn't have a variable, we didn't have to change it to exponential. We have 5. We can just shoot it to the other side, right? Leaving us with x squared minus 4x minus 5 equals 0. So what are the factors of this?
5.
Good. Which one's positive? Which one's negative?
The 1 would be positive.
Good.
So 1's your answer.
Okay, so this is interesting here. What are the x's equal to?
-1 and 5.
-1 and 5, right? Because you have to set it equal and change it. In this example, do we have to get rid of 1? We actually don't. Do you know why?
Because that's all for x.
Yes, and where's x not? It's not in the log. Y'all follow me? Remember earlier today I said throw out the -1? Do you remember that a little bit? Not really? We'll do one here in a second where that's what we'll do. But in this one, because the x is not here, we just subtract it over and you could have 2 different answers. Okay? Let me show you an example where you'd actually have to throw it out. So if you go down to the one we did yesterday, we'll go quick through it because I know we already did it. But if you go down to number 19, what do I do on that left side right here? How do I combine it?
You multiply 3x plus 7 and 5, x minus 2.
Good. Is equal to 1. What is the base of the log? 10. Great. Good. So how do I get that log out of there? Shoot the 10 over. Nicely done. And so what we have now, once we do that, once we have one log and we change it to exponential, the log does what? Goes away. Good. So we have 3x plus 7 times x minus 2 equals 10 to the first. Okay? Which 10 to the first is just 10, right? So on this left side, we can distribute 3x times x is 3x squared. We're just distributing, right? 7x minus 14 equals 10. What do I do now? I could, absolutely could. I would say move everything to the left, mainly because this is x squared. Cool? So we're going to subtract by 10. Subtract by 10. So this would be 3x squared minus 6x plus 7x minus 24 equals 0. Okay? What is negative 6x plus 7x? 1x. Good. So 3x squared plus x minus 24 equals 0. And what we can do is do a times c, right? So 3 times negative 24 would be 172. I'm going quick through this. Is that okay? Okay, so we got right now, I'm putting it way up here. I'm all over the place. If you're watching, I'm sorry.
Can you just do like the slide and divide thing?
Yeah, that's what I do. So the slide and divide, I do a times c, which is 3 times negative 24, which would be x squared, would turn that into, plus x minus 72 equals 0. Cool, that's how I do it. And then when I factor this, what 2 numbers when factored get me negative 72 when we multiply but added equal 1? Good, 8 and 9. And this would be x minus 8 plus 9. And then this is where I bring this 3 back into play, where I divide by 3, divide by 3. If it goes evenly, then you're good. But if not, you got to check it. So x plus 3, x minus 8/3. When I set them equal, what is x equal to here? -3 and positive 8/3. The real factor of this would be 3x minus 8, but it would produce the same thing. On this one, though, do you remember with a log, when we look at a log graph, well, like this is a good example of one. Everything is positive. Do you see that? Like here's the vertical asymptote. Everything's positive. So I can't have anything that produces a negative value, which is basically to the left side of that, unless it's a reflection. So when I look at this, if I plug -3 back in for my original, right in here, -3 minus 2 is -5. I can't find log of -5. That makes sense? There's no such thing. So that's why we cross off -3, and we only would have 8/3 as our answer. Okay? It's a good question. Good question there. Good stuff. Do y'all feel pretty good on 1-to-1?
Yeah.
Y'all feel pretty good there? Okay, cool. What about, like, this is a weird one with that 2 in front. E and ln can't cancel. It's a pretty quick one. So we can't cancel because it's not e to the ln. So what do we do with 2? Make it an exponent back here. So it'd be e to the power of ln of x plus 1 squared. Cool? Then they cancel. Then we only have x plus 1 squared left over. Cool? Which would be a. 1-to-1 is just where I change 16 to where it's 2 to the 4th equals 2 to the 7x minus 5, and then I cancel, and then I set them equal and solve.
Okay.
Cool?
Is this due?
This will be due tomorrow.
It will be due. Okay.
The front side, if you just try a couple of them, the one that's in the front is pretty tough. Did you see that one? Let's see here. Let me see if I can. See if I can actually get this one here. It's here. Let me see it. It's this one. Let's see. Yeah, let me see this one here. Like number 40. You see that one, number 40? Where it says the number n of bacteria is modeled by this. So n is the number of bacteria, t is the time in hours. Okay, so as time progresses, bacteria grows exponentially. So it says if n equals 280, or if the bacteria is 280 when the time of 10 hours, estimate the time required for the population to double in size. Okay, so the first part is 280 is n, so that would be 280 is equal to 250 e to the k times 10. The k is like our constant. What that means is it basically allows us to see how it's growing. How fast is it growing? Okay? So we go ahead here. How would I solve for a k on this? First of all, is everyone good with how I plugged it in? We're good. How would I solve for k? That's it. Yeah. So divide by 250. Good, because we want to get that e by itself. So that's where we get 28 over 25. You could use a decimal if you wanted to. But then that would be equal to e to the 10k power. So what do I do from here? ln both sides. Good. ln of e on the right side does what? Cancels, giving me 10k equals ln of 28 over 25. And so when I do ln of 28 over 25 and then I divide by 10 to get k by itself, that gets me a certain value. We finally solved for k. Probably could do it on mine. 0.0113. Awesome. Okay, so then the next thing says, estimate the time required for the population to double. Okay? Here's my question. I don't know. Are they talking about this double or are they talking about this double? I'm guessing it's this double. On the test, I'll tell you specifically if you have questions. But we're going to say that we're trying to double this. So what would n be? I would say, well, the new one. So
Oh.
we just solved for k, right? They're saying what would t be? What would the time be if the n doubled?
The 500.
I would say 500 is equal to 250 e to the k. Well, k is 0.0113, right? Times t. Cool. And what would I do then to solve for t?
Same thing you did last week.
Good. Divide by 250. We're just not solving for k anymore. We're solving for what t would be. So I would say 2 is equal to e to the 0.0113 t. ln, right? You got to get the idea. ln of each side. So then ln of 2 divided by 0.0113 would give me what my time would be.
Would you do ln of 2 first or
I would do ln of 2 first, then divide. Yeah, just be careful on that because sometimes that can throw it off. You're right. Y'all get it there?
Yeah.
Cool. Cool. All right. Did y'all get the T just so we've got it? Let's see here. Let's put it in.
It's 61.34.
Awesome. Thank you, Sophia. Appreciate it. 68.34. There it is. Good stuff. Did you have any other questions on, like, what about the calculator one? Like one of these down here? Y'all feel okay on that?
Oh, yeah. 15 and 16. I just don't remember how to do those.
15 and 16, let's see. Yeah, this one's tough. Mainly because we did them, but we didn't probably ask it quite like this. So I agree, this one's tough. Remember with log, the log is only restricted by my vertical asymptote. A vertical asymptote changes with horizontal change. So as I look at number 15, notice this is not 3 plus, so this is actually no type of transformation other than maybe a stretcher strength, like it will make it skinnier or wider. But we don't need to know that for up, down, left, right. Now the inside of the parentheses does what? Moves it right or left, right? It depends on what it would be equal to. So I could set 5x minus 2 equal to 0. And what would that do to my x equals now when I solve?
2
Good, yeah, we're just going to add 2. Divide by 5. And that would be 2/5. Good. And I say that really pushes the graph 2/5 to the right, which traditionally has a vertical asymptote at 0. So when I push it to the right, think of this as like, okay, I've got 0 traditionally. Here's 1. That means 2/5. The vertical asymptote will now be at 2/5.
So 2/5 to infinity.
Good, because this graph will look something like this, 2/5 to infinity.
Okay.
And the range would be
Infinity
infinity to infinity, or you could say all reals. That would work as well, but that would be number 15. All right, look at 16. Find the vertical asymptote and x-intercept. First off, again, same idea. Ln and log are like sisters of each other, kind of like e and exponential. So when you look at the transformations of 2 minus ln of 3 minus 3x minus 9, what does the 2 do? Yeah, we could if we're solving, but what type of transformation?
It goes up to, right?
Good, goes up to. What does the negative do? Reflects, flips, very good. And then 3x minus 9, that's where we set that equal to 0, right? Good, we add 9. Divide by 3. And we get 3 right here. So we would say that it would push it to the right 3, right? Right 3. So it reflects, goes up 2 and right 3. Well, what changes the vertical asymptote? The right 3. If I go up and down, you see how that doesn't impact it? But if I go right 3, that's how it changes. And so I would say that here, the domain, or the vertical asymptote, my fault, would be x equals 3 instead of 0. Cool? All right, right on. I'm going to have you do this real quick. Could you tell me what is the x-intercept? So set the y equal to 0, right, because that's what x-intercept does. And when I say 0 is equal to 2 minus ln of 3x minus 9, see with amongst each other if you can solve for that, okay? Cool.
I don't think you can do that. You're gonna have to get big.
How are y'all doing?
Not good.
Oh, not good? Is that what you're laughing about?
Yeah.
Alright.
Plug in your calculator.
Oh, this right here?
Could you not do
No.
that?
Actually, you could.
What?
Yeah,
How?
you could actually plug it in. Hey, I will say this though, for solving purposes, this would be good, okay? Alright, first of all, we're trying to get x by itself, right? Trying to get ln of whatever it is by itself.
The 2 over.
Move the 2 over, good. Good. What do we do now? Ln's still not by itself, right?
Divide by -1.
Alright, close.
Oh,
Divide by -1 first, right? Nice. So be 2 is equal to ln of 3x minus 9. Now what do we do, Claire?
E.
E, there we go. So we do E. We got to do it to both sides, right? And e to the ln on the right side cancels. So now we got e to the second equals 3x minus 9. Well, the rest is history, right? Because now we do e to the second, get that answer, add 9,
And then divide by 3.
divide by 3. Good.
And that's your x-intercept.
That'd be your x-intercept. That's just good for solving because we could have one like that tomorrow, kind of like on 3.4 quiz. Okay? How'd y'all feel on that 3.4 quiz?
Is that the one you just did?
Can I see what I got?
Yeah, it should be on the right side for your class there. No, I might have to go through some stuff, but yeah. Get your last test too. That might help as well as you're studying. Sophia, what did we get there?
5.46.
Perfect, thank you. It's not as bad as it looks, right? Just trying to get the ln by itself or the log or the exponential and then go ahead and start solving from there. Cool beans. How'd y'all do on the 3.5, 3.6 homework? Did y'all have any questions on that? Okay. We kind of did one similar to that, like there. That was what was due Sunday. I thought some people had some questions on it, but nobody hung around there for those, so they do. If you do have questions, you're watching this, go ahead and shoot me a text or something on that, and we can look at it together. What about these quick hitters? What about e to the ln of x equals x? Is that true? Yes, it is. E to the ln of x is just x, because these would cancel, right? Log base 1 of b equals b. Is that true? Well, we could maybe test this by shooting the 1 over to what side? So we would have b is equal to 1 to the b power. It's not true because, like, let's say this was 1. Oh, I'm sorry, that's a bad example. 2. That was bad. 2 is equal to 1 to the second. 1 to the second is 1 times 1, which is 1. That might not be true. Right. Log base b of b, is that true?
Yes.
Equals 1, yeah, because that cancels, and that would just be with the log. When it's the same value, we would just cancel b for 1. And so we would say the ones that are true is A and C. A and C. Good. Good, good. I think we've gone over almost every one. This one, y'all will love this one. Number 6 is extremely easy. A certain population increases according to the model. Use the model to determine the population when t equals 5. Well, p is population. T is 5, so what do we do with 5? Plug it in for t and then just solve it. Yeah, just make sure you plug it in right. We did this one, we did this one. Did we do the whole review? This one we have not done yet. You get the compound ones where you work backwards. No?
Do it really quick.
We'll do that real quick. What about, yeah, y'all looked at me like, yeah. 1, we can't do 1 to 1 here. I'm saying this, then I'll get to 2. So what do I change this 3 to the 5x plus 1 equals 5 to? Yeah, so we shoot the 3 over to the other side.
Would it be log 3?
So it'd be 5x plus 1 on the left side equals log base 3 of 5, which I could use my calculator there. Okay. Also, I know it doesn't say this, but I want to make sure. If this had like a 2 on the outside, I would first have to divide by 2 before shooting the 3 over. Don't multiply inside like that, because that's a exponent. That's just a integer. Okay. All right. Number 2, an initial deposit of $3,000 is made in a savings account for which the interest is compounded continuously. That's key. What does compound continuously mean?
PERT.
We're using our PERT formula. PERT. That's exactly right. The balance will double in 7 years. What is the interest rate for this account? Well, what is the rate helps me to understand that the only variable that I'll have on this is my You're right, rate, yeah, interest rate. Does that make sense? So if it says, what is the interest rate? Think, oh, that's the one I don't know and I'm going to have to solve for. What is the P here? 3,000, good. To the R, how many years will it double?
2.
7.
7. 7 years. And therefore, if it doubles, I don't know if I should ask this question, what would be the A if it doubles? 6,000. Yeah. So 6,000 would be here. Good. So how do I get R by itself?
Divide by 3,000.
Good. Kind of the same idea. Divide by 3,000. Good. The left side turns into 2 is equal to E to the 7R. And then what do I do to get E out of there? ln both sides. Good. So I'd have ln of 2 equals E and ln cancel equals 7R. And then therefore ln of 2, getting that answer. And then I'll divide it by 7. Okay. Make sure you do ln of 2 and then divide by 7 there. Okay? All right. Good stuff. I hope that helped y'all a little bit.
Thank you.
Went through a lot. If you all have any other questions, come and see me tomorrow morning, and we'll go from there. Y'all have a great day. Bye.